Find one the equivalent resistance of infinite ladder between points A and B. Second, the current that passes through the 2 ohm resistor nearest to the battery. The circuit diagram is shown in the figure. This is an infinite ladder of resistance. If we cut this ladder from here as shown in the diagram, then we find the same type of infinite ladder as seen from here, point A and B. So if we consider that equivalent resistance of this system is R, then we can replace this part by a resistance of R. Let R be the equivalent resistance between points A and B. Then the above diagram will change like this, and this is the point A and this is point B, and from here, because it looks like same as seen from A and B, so it will be transformed, this point will be replaced by R. Whole system will be replaced by the with equivalent resistance R. Now because this is in parallel and this is in series, so now the equivalent now let R be the equivalent resistance between point A and B, that is A and B. So this will be in parallel and this is in series. So equivalent resistance between point A and B will be equivalent of these three systems. So 1 plus 2 into R by R will be equal to 1 plus 2 into R by 2 plus R. This implies 2 plus R plus 2R divided by 2 plus R equals to R. Or solving it, now 2 plus 3R equals to 2R plus R square, or R square plus 2R minus 3R minus 2 equal to 0, or this implies R square minus R minus 2 equal to 0, or R square minus 2R plus R minus 2 equal to 0, or taking R from common. So R into under bracket R minus 2 plus R minus 2 equal to 0. This again taking R minus 2 common. The R minus 2 equals to R plus 1 equal to 0. This gives R equal to 2 or R equal to minus 1, which is not possible. So we have to take R equal to 2. Hence R equal to 2 ohm. So the new circuit diagram will be like this. This is 1 ohm, this is 2 ohm, and this is 2 ohm. And we have to find the current in this current flowing through this 2 ohm. Now consider I current is flowing coming from the battery, and at this point it is in this direction goes I1, so in this will be I minus I1. Now we can write I equal to E by R because R is the equivalent resistance, and value of I is given 6 by 2, so 3 ampere, so I will be 3 ampere. Now for this point and between 2 points, potential difference will be equals. So current in this circuit multiplied by resistance equal to current in the circuit multiplied by this resistance. So we can write I minus I1 into 2 equals to 2 into I1. This implies 2I minus 2I1 equal to 2I1, or this implies 2I equal to 4I1. Hence I1 equal to 2 by 4I equal to I by 2. And the value of I is 3, so equals to 3 by 2 ampere. Hence I minus I1 equals to 3 minus 3 by 2 equal to 6 minus 3 by 2 equal to 3 by 2 ampere, 1.5 answer. Find the readings of the 2 meters. A. Find the readings of the 2 meters as shown in the figure. B. Switch. The switch is thrown to the other side. What will be the readings of the 2 meters now? Give N equal to 4.3 volt, R equals to 1 ohm, this R equals to 50 ohm, resistance of ammeter is 2 ohm, and resistance of voltmeter is 200 ohm. If this value is given, now we have to solve this. So current distribution is shown here. This is open, so no current flowing through this line. Current is flowing in this loop or in this loop. Now current distribution is shown here. We are assuming that I current is coming from this, and I1 is going in this, so I minus I1 will go through this, and again it will be I and flowing in I, flowing in this circuit as I. So our current distribution is right. Now we can use KVL to solve the problem. So KVL in A, B, C, D, A, B, C, D, A. So this will be minus E plus IR, and current is going this direction, that is higher minus lower, so positive. So I into RA, and again plus I1 into R equal to 0. This implies I into R plus RA, I common, taking common, I into R plus RA plus I1 R, I taking this side, E equal to or plus E equal to 1. Again KVL in DVCD, in this loop, applying KVL. So in this I minus I1 current is flowing, so we are going from higher to lower. So minus of I minus I1 into RV, minus of I minus I1 to RV, and plus higher minus lower, so plus R into I1 plus R into I1 equal to 0. This implies minus I into RV plus minus I1 into RV plus I1 R equal to 0, or this implies I1 into RV plus R equals to I into RV. Hence this implies I equal to I1 into RV plus R by RV. This is question 2. So we have got the value of I in terms of I1, RV, R and RV. Now we can calculate I1 using this equation. In this equation 1, using 2 in 1, we have I1 into I1R, I1 into, that is value of I is I1 RV plus R by RV into R plus RS, so true, and plus I1 R equal to E. Hence I1 will be E by RV plus R by RV into RA plus RE plus R. Now this all value is given, so we can calculate I1. So putting this value, we get the value of I1 at 0.08 ampere. Again now from 2 I equals to I1 into RV plus R by RV, and we have value I1 0.08, and putting all this value we get here 0.08 into 200 plus 50 by 200, 0.2 250 by 200, 0.408 by 5 by 4, or 0.02 into 5 equal to 0.1 ampere. Now at we can see VD minus here we can write VD, and VD minus I into R equal to C. So VD minus I1 into R equal to VC. So VD minus VC equal to I1 R, 0.08 into 50, or 4 volt. So 4 volt answer. Now in the second case, switch is thrown at this point, connected to this point. So this will be a loop and this will be a loop. Again we are considering that I current is flowing through this loop, and here it is divided into I1 and I minus I1. So I1 will be through this, and I minus I1 will be through this, and at this point again will be I. So taking KVL in ABCDA, in this loop, so minus of E plus IR, and higher minus lower, so plus I1 into RA plus I1 into RA, again plus I1 R equal to 0. This gives IR IR plus I1 into RA plus R equal to E. This is equation 1. And KVL DVBCD DVBCD in this loop, then higher minus lower positive. So RV into I minus I1, lower minus higher, because we are going from higher to lower, so lower minus I1 minus of I minus I1 into RV, higher and lower, so higher minus lower positive. I1 into RA, again I1 into R equal to 0. This imply minus of I into RV plus I1 to minus plus I1 into RV plus I1 RA plus I1 R equal to 0. This imply taking I1 common, the RV plus RA minus I1 RV RA and R, IRV RA plus R, and taking this side I into RV. Hence I1 will be I into RV by RV plus RA plus R. This is equation 2. Now using the value of I1 in equation 1, using 2 in 1, that is IR plus I into RV by RV plus RA plus R into RA plus R equal to E. Hence I will be taking I common and dividing E by, so I will be equal to E by R plus RV into RA plus R divided by RV plus RA plus R. Now all value is given, so we can calculate 4.3 by 1 plus 200 into 2 plus 50 by 200 plus 2 plus 250, and solving 4.3 1 plus 200 into 52 by 252, 1 plus 10,400 by 252, 4.3 1 plus 41.26 equal to 4.3 by 42.26 equal to 0.1. Hence I1 will be from equation 2, the value of I1 0.1 into 200 by 20 plus 2 plus 50, 200 plus 2 plus 50, or 20 by 252 equivalent to 0.08. So VD minus VBC I1 to R plus RA equal to 0.08 into 50 plus 2 equal to 0.08 into 52 equals to 4.16 volt. Answer. Next topic is electrical measuring instruments. First one is Hindustan bridge. It is a simple electrical network to measure unknown resistance. It consists of 4 arms containing resistances. R1 and R2 are fixed resistance, R3 is varying resistance, R4 is unknown resistance, whose resistance is to be calculated. Here it is shown Hindustan bridge. This is R1, R2, R4, R3, and R1, R2 is known resistance, R3 is a variable resistance. Its value is we can vary this value, and R4 is unknown, which we have to calculate. And in this circuit, from B to D, a galvanometer is connected, whose resistance is Rg, and R4 is known, so we have to calculate the value of R4. And varying resistance is also called a standard arm. This arm is called a standard arm, in which varying resistance is connected, and this is a battery, and this is a key to run the current. Now working. When K is closed, that is this K is closed, galvanometer shows deflection. Now we vary resistance. If we close the this K, then current will be distributed, and because current is flowing through this galvanometer will show deflection, that is current flowing through this. So now we vary resistance, we have to vary this, that change this resistance, value of resistance is changing. We vary resistance in third arm R3 such that galvanometer shows no deflection. That is, in this case, current through galvanometer is 0, Ig becomes 0. This is the condition of valence Hindustan bridge, and now this condition is called valence Hindustan bridge. Now theory. Applying KCL at B. I1 will be Ig plus I4. This is equation 1. I1 equal to Ig plus I4, equation 1. And KCL at D. KCL at D will be I2 plus Ig equal to I3. I3 from KVL in loop ABDA. Now applying KVL in loop ABDA. So I1 into R1 minus of I1 into R1 and minus of Ig into Rg plus I2 into R2 equal to 0. So here we see that KVL in loop ABDA minus of I1 R1 minus Ig into Rg plus I2 R2 equal to 0. This implies I1 R1 plus Ig Rg equal to I2 R2. This is equation 3. Again from KVL in BCDB. See here BCDB. So lower minus of I2 into R4 plus I3 into R3 and plus Ig into Rg equals to 0. So here we see minus of I4 into R4 plus I3 into R3 plus Ig into Rg equal to 0. So we have this imply I3 R3 plus Ig Rg equals to I4 R4. This is equation 4. When Wheatstone bridge is balanced, that is when Wheatstone is balanced, Ig becomes 0. That is Ig, the value of Ig equal to 0. So equation 1, 2, 3, 4 reduces to I1 equal to I4. Equation 1 becomes I1 equal to I4 and equation 2 becomes I2 equal to I3. This equation B. And I3 becomes I1 R1. I1 R1 equals to I2 R2. I1 R1 equals to I2 R2. And equation 4 becomes I3 R3 equals to I4 R4. This is ABCD. Now from C we get I1 by I2 equals to R2 by R1. Let this is E. And from D I3 by I4 equals to R4 by R3. And this apply I2 by I1 equal to R4 by R3 because from dividing A by B we get I2 by I1 dividing B by A. So I2 by I1 will be I3 by I4 and here I3 by I4 is R4 by R3. So I2 by I1 will be R4 by R3. And again this imply I1 by I2, that is reversing. I1 by I2 will be equal to R3 by R4. This is equation F. Now from E and F, I1 by I2 R2 by R1, I1 by I2 R3 by R4. So from E and F, equation E and F, from E and F we get R2 by R1 equal to R3 by R4. So R4 will be R3 into R1 by R2. Now we have R3 is known, R1 is known, R2 is known, and R4 which is unknown, we can calculate this value. So this is the working of a Wheatstone bridge. We have calculated the unknown resistance, that is the R4 we have calculated using this formula. We know that R1 is a known value, R2 is known value, and R3 is also known value. That's all.